In this video, I'm going to cover 3 examples on the addition and subtraction identities as they pertain to sine, cosine, and tangent. So I'm going to first go over a sine example, then a cosine, then a tangent, so you can move around in this video if you need. But before we get into the actual problem, I want to talk about what we need to know in order to complete this problem. First off, make sure you do grab the appropriate formula. There is a different formula for sine of x plus y, sine of x minus y, so on for cosine, and then for tangent. So make sure that you are grabbing the appropriate one with the appropriate symbol, addition or subtraction. Second thing, take a look at the formula and see what you need to plug into that formula. For this particular formula for sine of x plus y, we need to know what is sine of x, what is sine of y, what is cosine of x, what is cosine of y. So we need to take a look at our given problem and see what information can we automatically plug in, and then what information do we need to find out. So looking at our problem, we are given that sine of x is equal to 7/8 in the first quadrant here, 0 to 90 degrees. And then sine of y is equal to 3/4, also in the first quadrant. So what the first quadrant tells us is that everything's going to be positive. If you take a look at your coordinate system, right, this is your first quadrant over here in this space. Both sine and cosine are both positive. Everything's positive in the first quadrant. You're either going to the right, which is positive, or you're going up, which is also positive. So we are given sine of x and sine of y. What it looks like we're going to have to find is what is cosine of x, what is cosine of y. All right, so the way that we're going to do that is I'm going to start by drawing out what our sine of x looks like. So we're told that sine of x is 7/8. What we know from that is that sine is opposite over hypotenuse, right? So that's what it represents, opposite over hypotenuse. Right, so katoa. So sine is opposite hypotenuse. So that means in the numerator, that 7 is my opposite. That means that 8 in the denominator is my hypotenuse in reference to my angle. Here's my angle here. So first off, opposite, that is opposite your angle. So if my angle is here, completely opposite, that angle is right over here. That means this is going to be 7. And your hypotenuse is always your diagonal here. So my hypotenuse is an 8, so I'm going to plug in an 8 right there. Now, we know that sine of x is 7/8, so we plug that in here, but what we need to find out is what is cosine of x, right? So cosine is adjacent over hypotenuse, okay? Adjacent over hypotenuse. So we already know the hypotenuse. The hypotenuse is 8, and it's going to stay 8. What we need to find is adjacent, and adjacent is going to be this one right over here. So adjacent is like next to your angle. This is our angle. It can't be 8, but because that's hypotenuse. Your diagonal is always your hypotenuse, so adjacent has to be this side over here. We don't know that side, but we can figure out what that side is by using Pythagorean's theorem. Remember, whenever you're trying to solve a right triangle, and we do know we have a right triangle here, you can find the missing side of a right triangle by using Pythagorean's theorem. So Pythagorean's theorem, remember, is a squared plus b squared is equal to c squared. So let's see, I'm going to say that we're solving for a, b is going to be our 7, and 8 is going to be c. If we square everything, 7 times 7 is 49. 8 times 8 is 64. If we subtract that 49 on both sides, we get that we get that a squared is equal to, I believe that is a 15 when we do that subtraction there. So we need to take the square root of both sides. We are going to take the positive answer here. We do know that this falls within the first quadrant, so it is positive. So the square root of 15 is just the square root of 15. That does not simplify. What that tells me is that my adjacent side over here is the square root of 15. So that means cosine of x is equal to the square root of 15 over 8. Okay? So we know what sine of x is. We know what cosine of x is. We know what sine y is. Now we're going to have to find cosine of y. So we're talking about a completely different angle. X is not the same thing as y, so I'm going to do another little mini graph over here for sine y. So here's our angle. We know that sine y is 3/4. Again, remember that sine is opposite over hypotenuse. So that 3 in our numerator is our opposite. The 4 in our denominator is our hypotenuse. So once again, we are solving for our adjacent side because we need to figure out what is cosine of y now. So we have to find our missing adjacent side. We do know that 4 is going to be our denominator since 4 is our hypotenuse there. We just need to figure out what our adjacent side is. And we are once again going to use Pythagorean's theorem in order to figure this out. So let's solve for A, saying that B is a 3 and C is a 4. When we square everything, 3 squared, 3 times 3 is 9, 4 squared, 4 times 4 is 16. When we subtract this 9 on both sides, I do get a 7 here. And when we take the square root of both sides, we get that A is equal to the square root of 7. Okay, so that means cosine of y is equal to the square root of 7. So in order to wrap this problem up, let's do a little bit of plug and chug here. So sine of x is equal to 7/8. We're multiplying that by cosine of y, which we figured out is the square root of 7/4, plus cosine of x, which was the square root of 15/8, times sine of y, which was given to us, was 3/4. So if we try and simplify this, so first off, remember when we are multiplying fractions here, order of operations, we multiply before we add. Numerator times numerator, denominator times denominator. So for this first multiplication, 7 times the square root of 7 is simply 7 times the square root of 7. You can't multiply a number times a radical together. They literally just merge. Over 8 times 4 is 32. Plus 15 times the square root of 15 times 3, or 3 times the square root of 15 is just that. Over 8 times 4, which is 32. That means the only thing left for us to do here, we already have common denominators, so why don't we just go ahead and combine this into one big fraction. So for our numerator, 7 square roots of 7 plus 3 square roots of 15. Again, those do not combine. You can only combine radicals if they have the same number underneath the radical symbol, so if they have the same radicand. 7 is not the same thing as 15, so you can't combine these together. So it would literally be 7 square roots of 7 plus 3 square roots of 15 over your common denominator of a 32. That would be our final answer for this problem on what sine of x plus y is. Cosine coming up next. All right, so our next example, cosine of x minus y. I already have the formula up on the board. So taking a look at this formula, we need to know what is cosine of x times cosine of y plus sine of x times sine of y. So again, we need to figure out what is cosine of x, cosine y, what is sine of x, sine of y. Taking a look at our problem, they give us that cosine of x is 4/5, and it's in the first quadrant, which means everything is positive. They also give us that cosine of y is 12/13. This one is in the fourth quadrant, so that's going to change a little bit of things for us. We'll talk about that in just a second here. So we know cosine of x and y, that was given to us in the problem. We need to figure out what is sine of x, what is sine of y. So let's start with cosine of x is equal to 4/5, so I'm going to draw that here. We're talking about our first quadrant. So cosine of x being 4/5. Remember that cosine is adjacent over hypotenuse. That is the definition of cosine. That's what it is, adjacent over hypotenuse. So that means adjacent is my numerator, hypotenuse is my denominator. So adjacent is 4. So in reference to our angle, adjacent is this side right over here. And our hypotenuse is always our diagonal, and that is a 5. So that means we're finding our height here. We're finding this side of the triangle is what we need to figure out in order to find sine of x here. So okay, so in order to find sine of x, remember that sine is opposite over hypotenuse. We don't know what that opposite is, so we are going to use Pythagorean's theorem in order to figure that out. So I'm just going to say we're solving for A. I'm going to say that 4 is our B, and we know that 5 is our C. Again, remember 5 is always your hypotenuse. Otherwise, your two legs of the triangle are your A's and B's. Squaring everything out, 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. When we subtract that 16 from both sides, we do get that 8 squared is equal to 9. And when we take the square root of that on both sides, we get that a is equal to 3. Remember, we know that this is in the first quadrant and everything is positive, so we do want the positive 3. So I'm going to fit that in right over there. So that tells me that sine of x, which is opposite over hypotenuse, opposite being 3, hypotenuse being 5. So that means that sine of x is equal to 3/5. So I'm going to put that right over here. Let's do the same thing, but now with cosine of y. Remember that cosine of y is in the fourth quadrant, so that's this one right over here. So that's going to change things up just a little bit. Now cosine is still adjacent over hypotenuse, so this is our hypotenuse right over there. Our diagonal is 13. Our adjacent in reference to our angle, so adjacent is right over here. So we're having to find sine, which means we have to find opposite over hypotenuse. So in order to find the missing side of the triangle, we plug that into the Pythagorean theorem in order to work that out. So let's say we're solving for a. B is going to be our 12, and C is going to be our 13. Squaring everything out, 12 times 12 is 144. 13 times 13 is 169. When we subtract 144 on both sides here, I believe here when we do this, we get 25. And when we take the square root of both sides, we get that a is equal to 5. Now, remember, we're finding, we are finding sine of y. Sine of y is opposite over hypotenuse. Now, one thing that we need to be aware of, and this is one of the parts of this problem that a lot of students could get messed up in here, is that we need to remember that not everything is positive. This first one up here, our cosine of x, our sine of x were all positive because it was in the first quadrant and everything is positive in the first quadrant. Cosine of y, sine of y, we're talking about the fourth quadrant, and not everything is positive in the fourth quadrant. Now if we take a look at this 12 in reference from our origin, that 12 we're going to the right 12. Now that's a positive 12. A hypotenuse is always positive, so we need to figure out this 5 here. Now this 5, this is going to the right 12, down 5. And because we're going down 5, because we're talking about the fourth quadrant, the space down here, that means that that 5 is actually negative. That is what that fourth quadrant tells us. Sine is negative in the fourth quadrant. So that means sine is, again, in reference to our angle, opposite, which is negative 5, over hypotenuse, which is 13. So plug and chug into the formula. Cosine of x is 4/5 times cosine of y is 12/13 plus sine of x is 3/5 times sine of y, which is negative 5/13. Let's see, multiplying before we add, 4 times 12 is 48 over 5 times 3, which I believe is 65. Plus 3 times negative 5 is a negative 15, over 5 times 3 is 65. Add your two fractions together, keeping the common denominator of 65. 48 plus a negative 15 gives us a 33. Check to see if the fraction can be simplified, but I believe this is it here. That means cosine of x minus y is equal to 33 over 65. All right, so here we're talking about tangent of x minus y. So again, remember that these sum and difference formulas here, each one of these formulas is different, whether they're positive or negative. So the negative one, tangent of x minus y, is right over here. Taking a look at this formula, so it looks like we need to know what is tangent of x, what is tangent of y. Otherwise, the only other thing we have in here is a 1, so that's fine. So taking a look at our problem, thankfully for this problem here, it was given to us a little easy for us. We are told that tangent of x is equal to 9. We are told that tangent of y is equal to 2. Those are the two things we need to know in order to plug into this formula. So we can go straight to plugging into this formula and simplifying the fraction in order to work it out. So starting in the numerator, tangent of x is equal to 9 minus tangent of y is equal to 2. Over 1 plus tangent of x, which is 9, times tangent of y, which is 2. Continuing to simplify, in the numerator 9 minus 2 is a 7. In denominator, I'm going to drop down that 1. Remember, multiply before you add. 9 times 2 is 18. And finishing that subtraction in the denominator, 1 plus 18 is 19. So here we get that tangent of x minus y is 7 over 19. That one was really that simple. Otherwise, that is it for this video.